analysis. And welcome to your Chapter 2, Lesson 5 notes. And we are looking at standard and vertex form of quadratic functions. So, parabolas, right? Quadratics. Let's take a peek at a nice, beautiful parabola and its pieces. So, quadratic function here, of course, we can see it's a function. There's no repeated x values. We have x-intercepts right here. So this is the roots, right, as another way to describe these, roots or zeros. That's another word or term we use to describe these guys, where we cross or touch the x-axis. We've always got this beautiful axis of symmetry. And those that know me know I abbreviate AOS for axis of symmetry when I'm talking about it. It's always a vertical line. So x equals the x value that it touches on the x-axis. So x equals 1 is the vertical line, the axis of symmetry in this particular quadratic. And then, of course, there'll be one y-intercept. I don't really focus in on the y-intercepts, but when we start to look at the equation, you'll be able to kind of see where that's coming from and use it. So this is just, the pieces that come together to create this parabola. Also, I just want to point this out because this is kind of something that I use when I'm graphing my quadratics, is there's not a slope, there's not a constant rate of change to these the way that there was with lines and with absolute value. But there is a rate of change occurring that has a pattern to it. And I just want to point it out to you if you don't mind, right? So if you start from the vertex, obviously we'll go in both directions here, but I'm just going to go to the right of it. If you go up one, right one, you get to the next point on each side. Up one, right one, up one, left one. You get to the points on each side. Now you go up 3 to get to the points. And then you go up 5 to get to the points on each side. And so that rate of change is in a pattern itself by 1, by 3, by 5. And so you can see that that is happening. Those next points are at 12 up on the y-axis, and those points after that are at 21 on the y-axis. And so that I'm following that rate of change as well. So it's another thing that you can kind of think about towards how the parabola becomes. And it's not a constant rate of change, but it is the, rate of change that has a steady change in itself. Okay. That's why these are curved and not straight, like an absolute value is straight. Alrighty, let's start with standard form. Standard form of a quadratic function is likely the one you're most familiar with, which is the ax squared plus bx plus c, right? So y equals makes it the function. If you just have this, you've got just the polynomial part of it, but you have this, you have two variables, you have the function. So this is where we have the axis of symmetry formula, x equals negative b over 2a, that kind of front and bottom part of the quadratic formula, right? And then this is what you can use to find the vertex points. All it is I'm showing you the algebra of having plugged in these pieces, right? So having plugged in those pieces as your x value and then plugged in the other piece to find your y value, okay? So that's how you figure out what the vertex is plugging this x in each of these spots where it would be. It obviously wouldn't be here. That would be just your number, okay? That's what's happening there. So I'm not expecting you to memorize that by any stretch of the imagination. I'm expecting you to know your axis of symmetry formula because, well, you're supposed to. We taught you that in Algebra 1, and it is the front and then bottom of the quadratic formula anyway. And once you use this, you can just plug back into the equation and find that y. I wouldn't even worry about what you're doing there. Now, here's where the vertex form is almost a little easier. And I know converting into vertex form is not easier, but the vertex form interpretation, look at it. It's just like that absolute value function that we were just doing, where This is the opposite sign of the value of the vertex. This is the correct sign of the value of the vertex. So HK is your vertex. This is your rate of change of the quadratic. Okay, so that same thing is occurring. Again, you have to have an A value. So you have to know you have to have an A value because there has to be an x squared involved, is essentially what we're saying. This just can't be 0 because if this is 0, there's no x squared, and now all of a sudden you're just a regular line. All right, but finding the axis of symmetry and turning point is just so much easier with this. Okay, when you're in vertex form, that part is a lot easier. There's pros and cons to each. Okay, we're today going to convert back and forth. This is something that you learned in Algebra 1. So while there will be a lot of algebra here, it is something that you have seen before. So what we're going to do is we're just going to convert back and forth. And what I did here is I showed you the same function in both forms. Okay, this function and this function are the same. And just real quick, oh, forgot I have it up here. Let's go to y equals. I'm just going to type in the first function, x squared minus 2x minus 3. That's going to be my blue one. And then I'm going to arrow down here, and I'm going to type in the second one, which parentheses x minus 1. Oh, I suppose I could look at it right there, huh? And then end parentheses squared, and then minus 4 off the end, so you can see both of those. And if you press graph, you'll see they end up being exactly the same, right? Started with my blue one, getting graphed, ended with my red one getting graphed. If you check second and graph to see their tables of points, their points are exactly the same with each substitute in. So what I'm showing you is just the back and forth of how to go from standard to vertex or vertex to standard. I think vertex to standard is easier because all you do is FOIL the binomial and then combine like terms. So that tends to be a lot quicker. Standard to vertex, you have to complete the square. And so a lot of you struggled with completing the square when it happened. I am going to go through it right here in this example, but I want you to bear in mind, it's right here with completing the square. This is where you get your x squared and your x on one side of the equal sign and put that plus blank on both sides. The blank gets filled in by taking this, dividing it by 2, and squaring it. 2 divided by 2 is 1. 1 squared is 1. That's how I know what goes on the blanks. And then this is now that's a trinomial that factors to become 2 binomials. And those 2 binomials are exactly the same, so they get written as 1 binomial squared. Okay? That's how we do this. And finally, you move that last number over to the end. That's what gets you that vertex form. Okay? So let me just show you. So right here, these are obviously not the same 2 functions. And the reason that I say these are obviously not the same 2 functions is because this one has a -1 as the a value, and this one has a -2 as the a value. And when considering, oops, almost dropped my blue light glasses. When considering these 2 forms, notice the a value is in both types, but the other letters aren't. The other letters are different. And that's because the a value is the same no matter what form you write your function in. So these are different problems. Okay, just wanted to point that out one more time. Okay, well, actually, the first thing you have to do if you have a negative a value is you're going to have to divide everything by -1 because you can't have any a value other than 1 with your x squared. So I'm dividing everything by -1. Just going to change everyone's signs. Now what I'm going to do is I'm going to move 9 to the other side of the equal sign just for a little bit. Just so in its place I can put a plus blank. And that's so I can fill in the blank and complete the square. This is the actual completing the square. If you put a plus blank on one side of the equal sign, you have to put it on the other. So the actual completing the square part is creating a perfect square trinomial here. 8 divided by 2 is 4. 4 squared is 16. This is always plus, so it's always positive, whatever that value is. Now, the benefit here is that this factors to become two binomials that are exactly the same. The factors of 16 that add to give me 8 are 4 and 4. And since 8 is negative in the middle, they're both a negative 4. So since these two binomials are exactly the same, they get written as one binomial squared. And that is the whole point of changing the sign, moving this over, and making this a perfect square trinomial. That's the whole idea. Now that you've got your binomial squared, let's deal with what's going on the left. These are both numbers, add them up. 16 minus 9 is 7. Bring down your minus y. Now, what I'll do right here is I'll subtract 7 from both sides. So I can just bring down my minus y and then put this minus 7 off the end. Okay, so it was a positive 7, got to move it by negative. Last thing is to get this negative back away from the y, because now the y isn't supposed to have that negative. Well, once you have this binomial squared, it doesn't change. The only thing that changes is what's around it. So like the number in front of it or the number behind it. So when you divide it here by -1, you're really just changing the sign in front of it to be a minus. So see, now we're matched back up with the a value we started with. Bring the binomial down, binomial squared. Negative divided by negative is a plus 7 at the end. There you are. How do you check these? What you do is go to your graphing calculator. So I'm going to the one on my screen. I'm just going to clear out what I had in there. Okay. But I'm going to start with y1. And this is where I'm going to put the original function. So negative, always start with the little negative down here. X squared plus 8x minus 9. Okay. So I put that in there. Now arrow down and put in the function you just found. So it starts with a little negative. Always start with that little negative at the bottom. And now put this function in. Okay. And when you press graph, they should come out to be exactly the same parabola. And they did. That's how I know I got it right. That's my check. That's my big check. And of course, you can press second and graph to get the points exactly matched up. By the way, look at that vertex, 4, 7. Oh, 4, positive 4, positive 7. Shape, it's negative, so it was an upside down, right? Frowny face, negative people, frowny faces. And there you have it. That's how we convert. That's the more difficult conversion. Of course, over here, I think that number 2, I think when you start with vertex form, it's easier to go backwards. I'm going to start by writing out, whenever I see a binomial squared, I write it out as the binomial times itself. And the reason I do that is because then I remember that I have to FOIL. So that's the first thing you should be doing when you see a binomial squared, is writing it out. And I'm going to keep my answer to this in parentheses just because then I have to distribute this -2, okay? So I'm going to keep the answer to my FOIL in here. But as I do it, I'm going to combine my middle terms. So just listen as I go. Ready? X times x is x squared. X times -4 is -4x. -4 times x is -4x. They add up to -8x. -4 times -4, positive 16 back here. Now distribute that -2. So you had to distribute a third time. -2x squared plus 16x in the middle, minus 32 at the end, and then bring down that plus 9, and that is the final feature. -2x squared plus 16x in the middle, 32, -32, and positive 9. So really subtract the numbers. 32 minus 9 is 21, right? What am I saying? 23, excuse me. And negative, right? So -23. I was treating that like 11. Anyway, now match them up. Make sure they're correct. Y equals cleared those out, go back up. Takes me longer than when I have the actual buttons in front of me, right? Negative 2 parentheses x minus 4 in parentheses squared plus 9. Arrow down. Negative 2x squared. See how that a value is exactly the same in both? And plus 16x. Sorry that I always look away from you guys, but I'm looking at my big screen. You'll see that. Got the big screen over here and it's more in my face. And now press graph to see them. And they should be, uh-oh, what'd I do wrong? See, now I know I did something wrong. Let's see what I did wrong. Maybe I really can't add. And I'm okay with that. It happens. Negative 23. Yeah. Positive 16x. Is that what I typed in? Anyway. Oh, guys. Sitting there trying to redo my math. I'm sure that like at home you screamed at me like, you just superimposed your numbers. I know. There we go. Let's try it now. Made me check, didn't it? Made me check my answer. Double check my math. And there we have it. All right, guys. I think you got this, but if you don't, come see me. We'll talk about it. I'll do more examples. Good luck. I'll see you soon.